Hello dear students, this is Mr. Muhammed Azeez. In this video we're going to continue on grade 12 book. Previously we stopped right here. This is a very important lesson. We're going to explain the relations between graph of f, f prime and f double prime. I have the relations as a table here. Whenever you see the function f is increasing, then we can directly say f prime is positive, or we can also say f prime is greater than 0. That's another way of saying it's positive. Whenever you see f is decreasing, then f prime is negative. And in these three relations, if you see any of them, you can write the other two. If you know f is convex, that means f prime is decreasing and f double prime is negative. If you see f is concave, then f double prime is increasing and f is positive. Let's simplify this table to two sentences, two mathematical expressions. Number one, whenever you see a function is increasing, we can directly say the first derivative is positive. So as a relation, if I add a prime here, so if I see f prime is increasing, that means f double prime is positive. Remember, any relation that is true or that is given between f and f prime, when you add a prime to each one, the same relation is true for f prime and f double prime, and so on. The question might give you some information about the third derivative. What if the question tell you, or what if the question says f triple prime is increasing? Which of the following is true? I know if anything is increasing, the next derivative, which is f fourth derivative, is positive. That's it. If any function is increasing, the next derivative is positive. And it's two-sided. The other way is true as well. It's vice versa. If the question gives you any derivative that is positive, that means the function before this derivative, which is f, is increasing. If a function said f fifth derivative of f is negative, I can tell the fourth derivative is decreasing. This is the relation. Now let's go back to the first one. If I know f prime is increasing, that makes f double prime positive. And if f double prime is positive, that has another meaning for us, which is f is concave. Okay? These are all two-sided. In these three pieces of information, if you see any of them, you can write the other two. Now let's write for the decreasing one. If f prime is decreasing, then f double prime is negative, which makes f convex. And these are two-sided as well. If I know f is convex, then f double prime is negative, which makes f prime decreasing. That is very decent. That's very important. You really need to know this when you enter Usari. Okay. Now let's talk about critical. I say fx has critical at x equal to a. If any function has critical at a certain value, then the next derivative, which is f prime at a, it's equal to 0 or undefined. For such relations, graphical relations, 0 is more common. So it's telling me, this relation is telling me, if any function has critical value, then the next derivative is 0. So what if I say f prime has critical value? That means f double prime is 0. And when f double prime is 0, we don't stop it here. If f double prime is 0, then x equal to a is point of inflection. Is point of inflection. See, if f prime has a critical value, F has point of inflection. Now what I said, let's say them all again on a graph. I searched 6 calculus books to find the best and the easiest to understand diagram relation between F, F prime, F double prime, which is here. You have it. You don't need to search so many books. It's right here. Look at this. If you don't use this pamphlet, if you are not using my booklet, just take a screen of this. You cannot find this anywhere else. Now, let's recall what we said before. Now look at this F prime, and this is F. If F prime is positive, I always look at F prime to see if it's positive or negative. F prime will be positive if it's above x-axis, and F prime is negative if it's below x-axis. Whenever F prime is positive, how is F? Increasing. Whenever F prime is negative, how is F? Definitely decreasing. Clear? If the graph of F is not given, only F prime, look from this point to the right, it is positive. That means the function from the same point to the right is increasing. From this point to the left, the graph is decreasing. I know from the point to the left, the derivative is negative. One more thing, there is a critical value. The critical is minimum. Right where the function has critical, F prime has x-intercept. F prime is 0. F prime is equal to 0, it means F prime has x-intercept. You know, in Wizari, they can mix these two. They can give you the graph of F like here and ask you how many x-intercepts are there on the graph of F prime. You just come down, you look at the graph of F, it has 2 critical values. That means F prime has 2 x-intercepts, here and here. Same points, same x values. Okay, that is x-intercept. At the same time, it is where F prime equal to 0. Because if, let's say this point is A, F at A has a critical value, which is minimum. It doesn't matter if it's minimum or maximum, it still makes F prime 0. Now for the second graph, this time I don't look at positive, negative on F prime. This time I look at increase, decrease on F prime. And we had 3 pieces of information. And I said in these 3 pieces of information, if you see any of them, you can write the other 2. If F prime is increasing, that means F double prime is positive, which makes F concave. And if F prime is decreasing, that makes F double prime negative, which means F is convex. Now, I look at this F prime from the angle of increase and decrease. This F prime is decreased from negative infinity all the way to this point, which makes F convex from negative infinity all the way to this point. F prime is increasing from this point to positive infinity. F is concave from this point to positive infinity. Now, if we look at this point, it's point of inflection for F, while it's critical for F prime. And how can I tell the critical of F prime is maximum or minimum? This side is convex. Convex is negative, and also negative means decreasing. This side is concave. Concave is positive, and we know positive is increasing. Now, this point of inflection on F prime forms a V shape. V shape means there is a minimum. Now, all the ideas you learned, you can confirm it with the third graph. Let's say from this point to this point, F is convex. When I look at F prime, I should see decreasing. I do from this point, from here until here, F prime is decreasing. F is convex. Let's say here, F is increasing. From this point, this green region, to positive infinity, F is increasing. What do you expect from F prime? I expect F prime to be positive. F prime itself is increase, decrease, I don't care. Okay? There is a very common mistake. students look at f and f prime both for increase decrease. That's false. When I look at f for increase decrease, I need to look at f prime for positive or negative. Positive negative means, is it above x-axis or below x-axis? The shape is increase decrease, the shape of f prime. I don't care. I only want the sign. Positive makes f increase. Negative on f prime makes f decrease. Now, if I look at increase decrease on f prime, then I should not look at increase decrease on f at the same time. No, when I look at increase decrease on f prime, I should check for concave convex on f. When I look at critical on f prime, I need to look for inflection on f. Okay, when I look at x-intercept on f prime, I need to look for critical value on f, which means maximum or minimum. All right, what I said, these are all golden notes. You can write these notes down. Here you have some space to write. Every information you catch, you can write it here. For example, now you know if f is increasing, f prime is positive. If f is decreasing, f prime is negative. If f has maximum or minimum, f prime is 0. You know, if f has inflection, f prime is going to be max or min. These are all knowledge that you need to know before entering Guzari. And finally, here is another graph. This is f, and this is f prime. Again, double check every knowledge you got from the explanation above. You can double check everything here. For example, this is x-intercept on f prime. Then that should be either maximum or minimum on f. To check if it's max or min, here on the side, look, this is very interesting. On the side of this point, the derivative is below x-axis, yani negative. Negative, if I make a table, that will be decreasing for f. This side, the right side of the point, is above x-axis, that's positive. And if f prime is positive, f is increasing. Now this point is located between decrease, increase. So this point must be minimum on f. Let's check. Is it minimum on f? For sure. Because what I say is 100% true all the time, no matter what. Alright, now let's go back and finish the exercises of section 2. Here we have some true-false, but let's finish these before the true-false. Here we have some relations between f and f prime. And yeah, this exercise. Alright, this exercise it's not solving. It is saying sketch the graph of a function fx equal to cubic root of x, that's x power 1 over 3, which is this S shape, and then graph the derivative and the second derivative, first and second derivative. Okay, and here we have all the three graphs. Let's recall some comparison between the graph of f and f prime along with f double prime. Here f is increasing, right? F is entirely increasing. This f is always increasing, which makes f prime to be always positive. This curve is f prime. It is above x-axis. This side is increasing, this side is decreasing. That's not what I'm looking for. When I say f is increasing, I have to say f prime is positive. Now if I look at increase, decrease on f prime, if f prime is increasing, f is concave, which makes f double prime positive. If f prime is decreasing, f is convex. This is f is convex, which makes f double prime negative. See? Let's say that again to make sure you understood. F is increasing, f prime is positive. Here f is increasing as well, f prime is positive. Here f is concave, f double prime is positive, which makes f prime increase. Here f is convex, which makes f prime decrease and f double prime negative. F prime is discontinuous at 0, which means the function is not differentiable at x equal to 0. F double prime is also discontinuous at 0, so x equal to 0 is vertical asymptote. Here, question 15, A and B, again, it's not solving, it's about sketch. Sketch a graph that has f prime less than 0, okay? And we want the derivative to be increasing. This is where a lot of students confuse. They say, how come derivative is increasing and negative at the same time? Positive negative has nothing to do with increase decrease for the same thing. Like if derivative is increase, it could be positive, it could be negative. If derivative is decrease, it could be positive, it could be negative. The derivative itself. Okay, look at 15a. 15a says f prime is increasing. Okay, look at f prime, it's increasing. And then f prime is less than 0. So f prime less than 0, it means below x-axis. The curve of f prime is increasing, although it's below x-axis. It's negative. If f prime is negative, f is going to be decrease. Okay? So not because f prime is increasing, f is decreasing. No. I never look at increase decrease of f and f prime at the same time. No. If I say f prime is increasing, I am confirming that f is concave. And if I say f prime is less than 0, which means f prime is below x-axis, that means f prime is negative, which makes f decrease. Now, this sentence in the beginning of the question, f prime is increasing, which means f is concave. F prime is below 0, f is decreasing. I'm looking for a function that is concave and decreasing. 15 part B, this time I want f prime to be increasing. Look at this curve, it is increasing. If f prime is increasing, f is concave. And f prime is greater than 0, which means the curve of f prime is above x-axis. For all the values of x, thus f is increasing. So f prime greater than 0, it means the curve of f prime is above x-axis. And f prime is increasing, which makes f concave. We said we have 3 pieces of information. If you see any of them, you can write the other 2. F prime increase, double prime positive, f concave. 16 is the same idea. This time it's decreasing. F prime decreasing. If I say f prime is decreasing, I can say f double prime is negative, which makes f convex. And if I say f prime is less than 0, that means f prime is below x-axis. Now, I'm going to look for a function that is convex and decreasing. Here should be a prime. The prime is not appeared in the print. Add a prime here. This is f prime. It is decreasing. This red is f. It is convex. And the curve of f prime is indeed below x-axis. And f is decreasing. Here, f prime is decreasing. That's it. You see f prime is decreasing. And f prime is above x-axis. It's greater than 0. That means f is increasing. F prime is decreasing. F is positive. F prime is decreasing. F is convex. That's what we get from the decreasing. F prime is greater than 0. That means f prime is positive. F is increasing. This graph is matching the description. In 2025, this question came back in Wazari. Let's find the right answer. It says, f is a function whose derivative is decreasing. Full stop. If f prime is decreasing, what can I tell? I can tell f double prime is negative and f is convex. I'm going to look for a convex function. This f prime is decreasing and the f is convex. This f prime is increasing, that's option C is out immediately. Option A is out immediately because it's increasing. And if you look at B, the function is decreasing, but the derivative is decreasing, but the function is concave. I'm looking for convex. B is wrong as well. D is right. If I could not make the decision between B and D, I had to read the question to the end. Determine a graph of f and f prime where f prime is greater than 0. If f prime is greater than 0, if f prime is positive, that means f is increasing. Then what saved the day? The relation. I said you need to know this for sure, then you go to Uzari. Here's a question. This question is extremely important because it makes f double prime 0 while it has no point of inflection. And because of this question, that they create true false out of it a lot of students confuse. This form of question, quadric bracket, x power 4 alone or bracket power 4, the graph is a U-shape. U-shape does not have point of inflection, it has critical, the critical is minimum, and second derivative when we find it is like 12 times 3 minus x minus 3 squared equal to 0. X equal to 3 makes the second derivative 0, but it is not point of inflection. F double prime 3 is equal to 0, but x equal to 3 is not inflection. Remember that bracket power 4 has the second derivative equal to 0, but it's not inflection. And if we do it normally, making the table, you will see around 3 that makes the second derivative 0. Both sides, right and left, are both positive, which means concave, concave. Point of inflection must be located between concave, convex, and the concave, convex should be connected. If they are not, then it's not inflection. This note is confirming the information. Quadric functions on the form of bracket plus or minus a number x plus or minus a number power 4 does not have point of inflection. And here, that's a very, very weak function. It's not important, but it is in the book. Let's not skip it. It says if a cubic function has 3x intercepts, then the middle one is going to be inflection. Instead of saying 3x intercepts, we can also say 3 solutions or 3 zeros. 3 zeros means 3 solutions. Okay. Now we have two Uzari questions that are very important. That's the relation between tangent, first derivative, second derivative, inflection, if. We use all of this knowledge to find the unknown. Let's solve this question. It is a very good question. For questions like this, since the options are A and B and we want to find A and B, we can use testing if you had no idea how to solve, but I don't recommend it. It's like a plan Z. If you had no way how to solve, then put A and B back into the function, see which one makes both sides equal. But when you find Y. Okay, let's solve this actually. Find the values of A and B for fx equal to ax power 3 plus bx squared plus 4. That has inflection point. Inflection point, that's a keyword. Point of inflection, it means f double prime of 1 equal to 0 because it says inflection at x equal to 1. So f double prime 1 is equal to 0. F double prime equal to 0 is inflection only for the bracket power 4. Double prime will be 0 and it's not inflection. Okay, another piece of knowledge is has tangent line. Okay, it's talking about tangent. Tangent is directly relation between f prime and slope. Here, tangent line, y equal to negative 3x plus 5 at the same point, bro. At the same point, is a weird way to confuse you. Why at the same point? Because they did not write clearly x equal to 1. They just said at the same point. And when you are nervous enough, you cannot see that. Then you'll be confused. You don't know what to put in place of x in the f prime to equalize to slope. Now, f prime of 1 is equal to slope of tangent, and slope of tangent is -3. Okay, let's work on the first relation. I want to find f double prime. I begin with f prime x equal to derivative 3ax squared plus 2bx. That's the first derivative. Now second derivative. Second derivative is 6ax plus 2b. Now put 1 in place of x and equalize the result to 0, as we know here. 6a times 1 is just 6a plus 2b equal to 0. Send 6a to the other side. 2b equal to -6a. Make b the subject. b equal to -3a. That's one relation between b and a. Okay, now let's work on the tangent. We use f prime. F prime of 1 is 6a. No, that's f double prime. F prime is right here. F prime of 1 is going to be 3a plus 2b. Okay, I can equalize 3a plus 2b, which is f prime 1. I can equalize f prime 1 to slope of tangent. Slope of tangent is -3. Now put this value of b here. We're going to have 3a plus 2 times -3a equal to -3. 3a minus 6a equal to -3. -3a equal to -3. a equal to 1. Look at the options. A equal to 1 is in A and B. Now I can use A to find B. If A is 1, B is -3 times A. So B is going to be -3 times 1, which is -3. Now A1, B -3 is this option. So B is the right answer. Easy. You just need to know how to relate inflection, tangent to F. Okay, the other questions have the same idea. Yeah, this one, we just studied the relation. Clearly, the graph of f prime is given and it says when f is concave. If f is concave, that means f double prime is positive, which makes f prime increase. This f prime is increase from 0 to positive infinity. Remember, in intervals of increase, decrease, concave, convex, in these 4 types of intervals, we only include x. Okay? Don't be confused with -4. This -4 is why we don't use it. We use the x, which is 0 all the way to positive infinity. This is the right answer. On this side, 0 to positive infinity, f prime is increasing, which makes double prime positive, and f is concave. That's what the question is asking for. This question is the last question for today. And no, that's not the last question. We have these true-false questions, and then we finish section 2, inshallah. Let's do the last question. Last question is not something very special. It's like the question we just solved. Point is given. Point is working on the function itself. Now I know f of 1 is equal to 4. We use this to find a relation between a and b. After that, inflection is given. Inflection point, that means f double prime of 1, because this point is inflection. For inflection, we only input the x into the second derivative. Result will be 0. Based on these two relations, we can find the value of a and b. After we find a and b, we use a and b to find f of -3. f of -3, after we find fx, we put -3 in place of x, and we'll find the value. It will be 108. True, false. The graph of a cubic function has exactly one point of inflection. That is true. The graph 1 over x, that's a tricky question. The graph 1 over x, let's graph 1 over x. 1 over x is positive on the positive side, negative on the negative side. Okay, look at this graph and let's read this out. Until here, everything is correct. The graph of fx equal to 1 over x is convex when x is less than 0. X less than 0 is this side, and the graph is actually convex. Concave when x is greater than 0. On the side, x is greater than 0, and the graph is concave. Yeah. Until here, it's true. Then it ruins it. It says, and has one point of inflection. On the graph of 1 over x, concave is not connected to convex. That does not form point of inflection between them. So that's false. 1 over x does not have point of inflection because of the inflection. It is false. Otherwise, for the concave convex, it's true. But when it says it has inflection and it does not have inflection, that's false. 23 is quite tricky. It's talking about f prime while mentions concave. Concave is related to f double prime to be positive, not f prime to be positive. That's false. Okay? And 24 is like the exercise we solved. I told you that they can create true false out of it. They already did. So f double prime is equal to 0, then that is inflection? No, because fx could be this function. If fx is like this, x minus 2 power 4, then it does have the second derivative equal to 0 at 2, but it has no point of inflection. That's false as well. And we already explained these. This is the end of section 2. Thank you so much for watching. Next lesson, we will start section 3. Good luck.